First topic review, I'm going to go through the matter questions. Now, you don't have to listen to me. I've got all the answers marked, but I am going to go through the headwork of what you should be thinking when you see each question. So it says a sample of only of atoms having the same atomic number. Well, everything that has the same atomic number has to be the same element. If I change the atomic number, that means I have a different element. So that's basically a definition. A dilute aqueous potassium nitrate solution is best classified. If you recall, when I went over the notes, we talked about heterogeneous and homogeneous mixtures, and we said that all solutions are classified as a homogeneous mixture. So that would be choice 2. Again, a definition. At which Celsius temperature does lead change from a solid to a liquid? For this, you need to look at Table S. You're going to find lead, and you're going to see that it melts at 600 Kelvin. 601 Celsius is there. Please don't get distracted. You need to change Kelvin to Celsius by subtracting 273 from it. The formula to convert is on the back of your reference table in Table T. It is not something that you have to memorize. The closest that it comes to is choice 3, 328. In number 4, which statement describes a chemical property of hydrogen gas? Remember, a chemical property is going to create a new substance. It is not something that I have the ability to get back. So if I burn hydrogen gas in air, I can't get it back. However, hydrogen gas being colorless, that's a physical description. Hydrogen gas having a density of 0.0009 is a physical characteristic. Hydrogen gas with a boiling point of 20 Kelvin is also a physical property. So, once again, you're looking for something that's going to change the substance. In question 5, which element has the greatest density at STP? You're going to look this up in Table S. You're literally going to write the densities down next to the choices to keep you focused. I didn't do that, but it's a lot easier if you actually physically write them down next to each choice and then see which one has the greatest density. In question 6, which statement describes a chemical property? Here we are again, chemical property. So I'm going to change the substance, okay? Magnesium being malleable. Malleable means bendable, right? Aluminum is very bendable. So is magnesium. Magnesium having the ability to conduct electricity. These are physical properties. So is boiling point. However, whenever you see the word react, magnesium reacting with acid, that word reacts means I'm going to change that substance and I won't be able to get it back. That is a chemical property. Matter that is composed of 2 or more different elements chemically combined in a fixed proportion. That is the definition of a compound. It's 2 or more different elements and they have to be chemically combined. That's why compounds can only be taken apart chemically, because they're put together chemically. Going up to the top of the next page, number 8. Which element is a solid at STP and a good conductor of electricity? There's 2 things going on here. First, let's separate the easy one. A good conductor of electricity means it has to be a metal. Well, choices 1 and 4 are nonmetals. Choices 3 and 2 are metals. So now they want to know a solid at STP. Standard temperature is 273 Kelvin. And I look at nickel. Nickel's melting point is 1728 degrees Kelvin. So if I'm at standard temperature, which is 273, Nickel has not melted yet. It is a solid. If I were to look at mercury, though, find mercury. Mercury melts at 234 degrees. So if I'm at 273, that means mercury is a liquid. So my answer was choice 3. The table below shows masses and volume data for 4 samples of substances at 298 and 1 atmosphere. Which 2 samples would consist of the same substance? You know you're given 2 characteristics here, mass and volume. Mass and volume give us density. So mass divided by volume, if 2 substances are the same, they should have the same density. In choice A, 30 divided by 60 is 0.5. In choice C, 45 divided by 90 is 0.5. They have the same density. None of the other pairings will give you the same density. In question 10, bronze contains 90 to 95% copper and 5 to 10% tin. Because these percentages vary, bronze is classified as a mixture. We gave the definition of a mixture earlier. Mixtures, right? The substances retain their own physical properties and they vary. If they're put together by physical means, we separate them by physical means. Compounds, on the other hand, have a unique proportion. If I change that proportion, I no longer have that compound. In number 11, a STP, which list of elements contains a solid, liquid, and gas? Here you have to know a little bit about the periodic table. So first of all, most of your metals are going to be solids, right? There's only 2 liquids on the periodic table at standard temperature and pressure, and we went over them when we were going over the review notes. It's bromine and mercury. So there's only 2 choices that have either mercury or bromine in the middle position of a liquid, and that's choices 1 and 3. 2 and 4 are definitely out. If I look at choice 1, hafnium is a solid, it's a metal. Barium is a solid, it's a metal. So for choices 1 and 3, the first and second position for solid and liquid both check out. The last position we have is a gas. Well, we know helium is a gas. Boron, if I didn't know was a gas, I could go to table S. And when I look up boron, which is element 5, it says its melting point is 2,348 degrees Kelvin. Well, if I'm at 273, that most definitely is a solid. So choice 1 was our answer. A 10-gram sample of which element has the smallest volume at STP? About this, if they're all 10-gram samples, the one with the smallest volume would be the one with the greatest density. Because if I take 10 and I divide it by a large number, like 10, I get 1. But if I take 10 and I divide it by a small number, like 1, I get a large number, 10. So I'm going to go to table S and I'm going to look for the one that has the greatest density. At room temperature, a mixture of sand and water can be separated by what? We went over all 4 physical means of separation: filtration, evaporation, distillation, and chromatography. So sand and water, we would use filtration. We actually did a lab on this. The filter paper will trap the sand and the water will go through. Okay, moving on. Which particle diagram represents a sample of one compound only? So first of all, a compound is 2 or more different elements chemically combined. So take a moment and look at my notes here. In box 1, this is a diatomic element. I have 2 particles that are exactly the same. This could be Cl2, Br2, O2. In box 2, I have a mixture of two different diatomic elements, perhaps Cl2 and O2. In box 3, I have a mixture of two different compounds. Maybe one is water, H2O, and maybe the other is carbon monoxide. It's only figure 4 that has one compound. I have two different particles attached, and all of them are the same in the box. In question 15, a 1 mole sample of neon gas occupies a volume of 24.4 liters at 298 and 101.3 kilopascals. Calculate the density of this sample. You have to include a correct numerical setup and a calculated result. So density is equal to mass divided by volume. They gave us the volume. In order to get the mass, we need to look at the periodic table. So I go to neon on the periodic table and I see it has a mass of 20.180 grams. And then I divide. In an investigation, a dripless wax candle is masked and lighted. As the candle burns, a small amount of liquid wax forms near the flame. After 10 minutes, the candle's flame is extinguished and the candle is allowed to cool. The candle is masked. Identify one physical change that takes place in this investigation. Well, one thing is the wax melting. It's going from a solid to a liquid. One observation that indicates a chemical change has occurred in this investigation. The wick burning is one example. Another thing that you could have written here is if we knew the mass before and after, and they are different, then we'd also know some type of chemical change took place. But the wick burning is the most obvious. It says draw a particle diagram to show the solid wax to liquid wax. It says use a dark circle for particles of wax. I didn't color mine in, but you should follow all of the directions. So in a solid particle diagram, all of the circles are connected and they make the shape of a crystal lattice, which is a square. In a liquid form, they're separated a little bit further apart with a tiny bit of space between them. If it were a gas, those particles would be spread out as far as possible in the container. Okay. Again, we're given 3 different types of atoms. We have X, Y, and Z, and they want to know which sample represents a pure substance. Hopefully, you can identify sample 1 as a mixture of both diatomic elements, the two X's together because they are the same, and monatomic elements, maybe neon. In sample 2, we have a mixture of monatomic elements, clear circles and dark circles. And in sample 3, it looks like we have a bunch of diatomic elements, but they're certainly all the same. So that is our pure sample. It then tells us when 2 atoms of Y react with 1 atom of Z, a compound forms. It says using the number of atoms shown in sample 2, which is our middle sample, what is the maximum number of molecules of this compound that can be formed? Well, if you look, we need 2 Y, and there's only a total of 5 Y atoms in sample 2. I need 2 Ys to react with 1 Z. Therefore, I can only make 2 molecules. And then it says explain why XX is not a compound, and that is because it is the same substance. They are identical. Okay, so that ends our first video on topic review for matter.